Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Next section is about how do we configure both global unicast addresses and link local static addresses. Alright, so what you end up having to do is you navigate to an interface, and just like you would an IPv4 address, you type IPv6 address, give it the address, but you'll notice this is going to be in slash notation. And then of course you turn it on. The assumption is you've already enabled IPv6 global unicast addressing on the router or on the device itself. So you have to make sure that IPv6 is already on. Similar to IPv4, with all of the commands that involve IP, if you add the v6 to it, almost always it will work. And again, don't forget to use the question mark if you're not sure the syntax of the structure. Like again, IPv4, you do the IPv4 address, you'd put the IP address space in dotted decimal form the subnet. With IPv6, you're using slash notation. That's why I'm saying you can always use a question mark to figure out how the command should go. If we're looking at a in device, again, you will have the same thing. You'll have the subnet prefix length, you'll have the addressing, you'll have the default gateway. You can also have this set for DHCP or SLAAC if you're being used. Again, you're going to have a automatically assigned link local address, or you can define it yourself with the IPv6 address and then put the address in and you denote it with a link local command. This is basically allowing you to configure it manually without having it auto-configure. So, dynamic addressing for global unicast addresses. Devices obtain these addresses dynamically through ICMP-v6. There are a few router characteristics that we have to understand how these addresses actually get obtained. Router solicitation and router advertisements and router acknowledgements. So a solicitation messages are sent by the host to discover the routers. Router advertisements are the messages sent by the routers to inform the hosts how to obtain that information. Part of that information will include things such as the network prefix and the prefix length, the default gateway address, if there is DNS addresses available, the domain name, if available. The router advertisements provide 3 methods for configuring the address. SLAAC with a stateless DHCP server, or stateful DHCP with no SLAAC. Remember, SLAAC is the auto configuration, and don't worry, we're going to discuss all 3 of these in depth in the upcoming slides. Alright, so method 1, SLAAC. So SLAAC allows the device to configure a GUI without the service of DHCP. The device will obtain the necessary information from the configuration from an ICMP-v6 router advertisement message from the local router, the local layer 3 device. Basically, the prefix is provided by the router advertisement, and the device will either use a EUI64 or a randomly generated method for the interface ID. A EUI64 basically looks at the MAC address, and then it sticks FFFE in the middle, and it will flip one additional, I believe it flips the 7th bit of the MAC address, and that is what creates the EUI64. Method 2, SLAAC and the stateless DHCP. So again, router or device comes online, it will send a router solicitation. The router solicitation will go to the local router. The local router will send a router advertisement saying, hey, this is where information that I have. And then the router advertisement will also give the default gateway, and then the rest of the configuration will be sent to the stateless DHCP server. Essentially, the router says, here's my information, here's the information for the DHCP server, get the rest of it from the DHCP server. And the DHCP server is going to be things like DNS, the domain name, and information like that. The third method is a complete stateful DHCPv6 deployment. Basically, device will come online, we'll send a router solicitation. The router acknowledgements, or the router advertisement, the RA message, will suggest that the device use the following information. The router link local address, which the RA sources the IPv6 address for the default gateway, and then it will also then say get everything else from the DHCP server. So the stateful DHCP server will obtain the address, the DNS information, domain name, and any other information. So stateful DHCP will use the link local address of the router, and everything else comes from the DHCP server. So we already talked about the EUI process a little bit. So how is this going to work versus a randomly generated interface ID? Again, the interface ID can either be done those two ways. So the EUI process is, again, it will split the MAC address in half, and will add FFFE in between, and then it will also flip the 7th bit. So basically, the 7th bit of the MAC address is reserved from the binary 0 to 1, so it flips it. A randomly generated interface ID will depend on the operating system, and instead of using the MAC and the EUI64 process, it will just essentially create a randomly generated one. Beginning with Windows Vista, Windows uses randomly generated instead of a EUI64. Keep in mind that IPv6 does have a duplicate address detection. This is very similar to ARP and IPv4 to verify that no two devices have the same global unicast address, or there are not duplicate link local addresses on the same local network. Moving on, we have our dynamic addressing for IPv6 link local addresses. Alright, so first and foremost, all IPv6 interfaces have to have a link local address. The link local addresses can be configured dynamically. They are created using a FE80::10 prefix, and they decide to use the EUI64 process more often than not. Though sometimes they can use a randomly generated number depending on the operating system. Here we have an example using Windows. I believe it is Windows 10 in this example, where you can see the similarities between the MAC address and the IP address, the IPv6 address. So that is how you can tell if it's using a EUI or if it's using a randomly generated one. Because again, if it's randomly generated, then they're not going to see the commonality between the addressing and the MAC address. Or you will not see that FFFE in the middle. That's another dead giveaway. So Cisco routers automatically create a link local address whenever a global unicast address is assigned. So they end up with both. The Cisco iOS will use a EUI64 to generate that interface ID for all of the interfaces it has. If we look at this example, they're looking at gig 000 on the device, and you can see the link local address, and you can compare that with the MAC address. Again, the MAC address is split in half, FFFE is inserted in the middle, and the 7th bit is flipped. So you can see the function, you can see the similarities between the link local address, the FE80 address, and the MAC address. So okay, that was. Oh, you can also do the show command to verify. You can do a show IPv6 interface brief, and that will show you the IP address. If you do a show interface and give it the appropriate interface, you can see the MAC address. We have a packet tracer lab to show and do the configuration for IPv6 addressing. We have the next section, which is all about multicast addresses. And again, a multicast address will have a prefix of FF00. There are two types of multicast addresses: a well-known multicast address and a solicited node multicast address. It's important to note that multicast addresses can only be the destination address, not the source. Typically, the source will always be a unicast address. So a well-known IPv6 multicast address, there are certain types of groups that are reserved. Basically, they're predefined groups of devices. Here are two common multicast groups. FF02::1, this is an all node for multicast group. This is the multicast group that all IPv6 able devices will join. We also have the FF02::2, which is the all router multicast group. This is basically the multicast group that all IPv6 routers will join. You remember that you have to turn on IPv6 addressing by issuing the IPv6 unicast routing command in the global configuration. The command is IPv6 unicast TAC routing. That enables IPv6 for that device. Again, these are just two of the multicast groups, not all of them. Remember that with an IPv6 interface, it will have multiple IPv6 addresses assigned to it, and that includes the multicast group addresses. And again, this is a well-known review for multicast. The next one is going to be solicited. A solicited node multicast address is similar to an all node multicast address, which is similar to a broadcast. A solicited node multicast address is a map to a special Ethernet multicast address. The Ethernet NIC can filter the frame by examining the destination MAC address, without even having to worry about sending the IPv6 process to see if the intended target is IPv6. We have a lab identifying the appropriate addresses. Moving on, we have our subnet for an IPv6 network. Again, we've already talked about the 64-bit prefix and the 64-bit interface. The prefix will be part of the global routing prefix and the subnet ID. That will determine the overall 64-bit prefix. Basically, a separate subnet ID filled in the global unicast address portion will be created. This creates the subnets. Here we have all of the different subnets. We have a /48, so the first 48 bits are the same. Only the next 64 bits are going to be different, and that will create additional subnets. Remember that the prefix is the first 64 bits. On the screen, the diagram shows the 64 bits, with the last 16 bits being the varying bits or the subnet bits. So in the example topology, it will require 5 subnets. So we will get 5 subnets, and we could identify them and we can distribute them. How do you do the router configuration? We've already shown how to configure an IPv6 address. You have to make sure to enable the interfaces as well. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.